Okay, so for this one, we're supposed to use source transformation to determine if the 6-volt source is supplying or absorbing power. So source transformation is kind of interesting. It can be a useful tool for solving circuits, but you also have to be careful that you don't change the thing that you're actually looking at. So for example, I'm supposed to be looking at our 6-volt voltage source. I don't want to transform that in any way. I want to leave that one alone. The other stuff I can transform. And what you can remember is that voltage source plus resistor in series can be transformed to a current source plus resistor in parallel. And this is actually a two-way thing. So voltage source and resistor in series, current source and resistor in parallel. So has to be that, can't be the other way around. Resistor doesn't change. And use Ohm's law to find the value of the new source. Also, you will use this method a lot of times when you have a circuit like the one we have here. And if you look at the one we have here, then you can see that this 20 ohm resistor and the 30 ohm resistor, they're not in parallel and they're not in series. And the same is true with the 5 ohm resistor and the 20 ohm resistor. They're not in parallel, they're not in series. And so you can't combine them using just, your regular rules because they're not in either series or parallel. But I do have a voltage source in series with a resistor, and I can change that to a current source and a resistor in parallel, and then that will be helpful because then I'll have two resistors in parallel which I can combine. So I'm going to redraw the circuit, and I am not going to write in the values of the resistors each time I redraw except for the ones that I need. Okay, so I changed the voltage source to a current source. The arrow is pointing in the direction of the positive terminal, so that's how you know what direction to point the arrow. And we'll use V equals IR to determine the value of the current source. The voltage was 40. The resistance is 5, so I equals 8. Now my 20 and my 5 ohm resistors are in parallel, so I can combine them with product over sum. So 20 times 5 over 20 plus 5 equals 100 over 25 equals 4. Okay, so now I have reduced my circuit to that, and I see that I've got a current source and a resistor in parallel. So now I can go backwards and turn that into a voltage source and a resistor in series. So I will do so.
Didn't you miss one of the resistance?
This
The one that is
one,
in the bottom?
that one,
Mm-hmm.
yes, thank
Yeah.
you. I did. Okay, so let's see. This was 6 and this was 10. And now this is V equals IR. It was a 4 ohm resistor and an 8 amp current source. So my voltage will be 32. Okay, now the next thing is something that bothers people sometimes, or I don't know if it bothers them, they just don't see it. If you look on the right-hand branch, everything on the right-hand branch is in series. The 10 ohm resistor, the 32 volt voltage source, the 4 ohm resistor, and the 6 ohm resistor. As long as I'm not interested in anything that's in between two of the resistors, which I'm not, then these are all in series, and I can combine them just like any series resistors, despite the fact that they're not like right next to each other. I can make that all one 20 ohm resistor. So I combined all of those. And now I'll do yet another source transformation. I'm getting close to the end now. And V equals IR. We had 32 equals I times 20. I equals 32 over 20, 8/5. Yes. And this resistor was 30 ohms. So now I can combine the 30 and 20 ohm resistor with product over sum. So 30 times 20 over 30 plus 20 equals 600 over 50, which is 12.
Can you explain how you're able to put the 20 ohm resistor in parallel with the 30 ohm resistor?
That's just the rule for source transformation. So for source transformation, yeah, that's what we're looking at in this problem. It tells us that if we have a voltage source and a resistor in series, which we have here, we can transform that into a current source and a resistor in parallel, and they have the same behavior.
Okay,
And
perfect.
so,
Thank you.
okay, yeah, because that's how it works. Yeah, it's kind of like magic, and to be honest with you, I don't like it one bit. I don't like current sources in general, but yeah. So I'm not a big fan. Let's see, so this is now 12. And 8/5. And this was 6 volts. And notice I have not messed with my 6 volts. And so I think we're ready for our last source transformation, is to take our current source and our resistor. So we've got current source and resistor in parallel. We're going to change that to a voltage source and a resistor in series. So we'll have and V equals IR. So I was 8/5 and the resistor was 12. I actually did not do this step. But okay, so this is not how I have it in my notes, but we'll do it. We'll do it anyway. Always a danger when I do it differently than in my notes. So I get 19.2. Did y'all get 19.2? Did anybody do it?
Yes.
Okay. So then
Yeah, I got 19.2.
all right. And what is your guess here about whether the 6-volt voltage source will be absorbing or supplying power? Well, my guess would be that it would be absorbing, because if I make ground here, then the potential here is going to be 19.2 and the potential here is going to be 6, and so the current is going to go this direction, which would be into the positive terminal of the 6-volt voltage source. And we can go ahead and figure out what the current is. Are we supposed to find? Just says if it's supplying or absorbing power. So it doesn't say to actually find the power, but we can do that. I is going to equal 19.2 minus 6 over 16. So we take the voltage on the right-hand side minus the voltage on the left-hand side and divide by the resistance. And I get that the current is 0.825 in this direction. So the current is in that direction. So the current is entering into the positive terminal of the 6-volt voltage source. And so that means that power is absorbed. Okay, questions?
Can you go over that last part again when you got I and then how you solved the power and stuff?
Okay, sure. So I had, this is a good thing to look at. So this was, the voltage here is 19.2. The voltage here is 6. Whenever I want to find the current going in a particular direction, I take the voltage where I'm starting from minus the voltage where I'm going to over the resistance. So I wanted to find the current in this direction. If I'd ended up in it with a negative number, that'd be fine. It would just mean the current was actually going the other way. But I did it this way because I saw that that would be positive. So 19.2 minus 6 over 16, and that gave me 0.825 amps. So that is my current. And now to find my power, I take my current with the sign that it has. So the sign that it has is positive, which is 0.825. And then as it goes into the voltage source, I take the sign that it's going, the sign that it's entering into the voltage source, which is positive. So P equals IV. And that gets me 4.95 watts, which is positive, and positive means absorbed.
All right, thank you.
You're welcome. Let me just check real